Hello everyone. This lecture video introduces 7 fundamental derivative rules with some examples. First rule is the constant rule, and this can be applied to a function y or fx equals constant number. Then the derivative of the function is 0. Before we look at some examples, there are various ways to express derivative notations, such as y prime, that is same as f prime of the x, and we can write it as dy dx, which is differentiation of y with respect to x. And also we can write dfx dx, which is differentiation of the function fx with respect to x. And instead of writing dfx, we can abbreviate to df dx. And also, we can show the function explicitly as the constant number c, the c dx, which are all equals to 0. Examples of the function where you can apply constant rule are first y equals 2, then the derivative of the y is 0. Also, when the function fx is given to you as any constant number, let's say 7, then f prime of the x is again 0. Constant multiple rule can be used when a function is multiplied with a constant number and asked to find a derivative. So the function will be given to you as y equals to c times fx. Then the derivative form of the function is, in this case, we keep a constant number as coefficient and find the derivative of the function. So that is y prime equals c times f prime of x. For example, when a function is given as y equals 8 times fx, then the derivative of this function is y prime, that is 8 times f prime of the x. Power rule is a way to find the derivative with function with different degrees of the powers. When function y is given to you as x to the power of n power, then the y prime is n times x to the n minus 1 power. We can put down the exponent as coefficient and subtract 1 from the original exponent we had. Looking at the example, when gx is 10x to the 9th power, then g prime of the x is equals to 10 times 9x to the 9 minus 1 power, which is 90x to the 8th power. Next, when hx is given to you as x to the negative 7th power, then the derivative of h prime x is negative 7x to the negative 8th power. Next rule to see is sum and difference rule. Sum and difference rules could be used in any polynomial functions, as we can break down the original polynomials into sum or difference of smaller functions, like hx could be sum of fx plus gx. Then the sum rule says the derivative of a sum of a function is sum of their derivatives, which is hx equals f prime of x plus g prime x. And it also applies in subtraction as well. So this includes minus sign in between the functions. Looking at the example of sum and difference rule, when we have hx, that is x to the 8th power minus 2x plus 1 over x squared, we can break the hx into the sum of fx and gx, like x to the 8th power to be our fx and negative 2x plus 1 over x squared to be our gx. Additionally, we can break the gx function into two monomials as well. That means we can just differentiate each term separately when polynomial functions are given. And we can change 1 over x squared to x to the negative 2nd power, which is a power form. When you find the derivative of hx, h prime x, that is 8x to the 7th power, minus 2 times x to the negative 3rd power, which is 8x to the 7th power minus 2 over x cubed. We'll see the product rule, quotient rule, reciprocal rule, and chain rules with examples in part 2 video. Thank you very much for watching the video, and good luck on studying.